the right-angled triangle. A right-angled triangle is characteristic of one which has 90 degrees as one of its angles. Okay, so and this 90 degrees now is represented by a rectangle. Okay, and the hypotenuse now will be away from the 90 degrees. So you can even see that edge of the 90 degrees is like the head of an arrow pointing towards the hypotenuse. So the 90 degrees always represented by a rectangle, and you can, denote it as pointing towards the hypotenuse. So the diagonal is the hypotenuse, and the two sides that form the 90 degrees, their labeling depends on certain factors. So for example, if there is a right angle triangle whose acute angles are not labeled, bear in mind this must be two acute angles because the total angles in a triangle is 180 degrees. So if one is already 90, the two others must add up to 90. All right, it must be less than 90 for them to add up to 90. So therefore now, the two acute angles, if they are not labeled, then the sides, the hypotenuse is labeled C. All right, and any of the other two sides that form the 90 degrees is labeled A and B. Very commonly, they put the A in the side that is horizontal, and put the B with the side that is vertical. But it doesn't matter. You can put the B horizontal and put the A vertical. So that's how you label a right angle triangle when the two acute angles are not, given, when they are not given. So if you're only concerned about the sides, then you would label the sides ABC, and C will always be the hypotenuse. Okay, C will always be the hypotenuse. All right. Now, what if an angle is given? All right. What if one of the acute angles is provided? Let's call it alpha. Okay. So for example, what if alpha is placed here? Very commonly, you'll see, a right angle triangle, and alpha is normally placed right there by the horizontal line, the horizontal side, if you want to put it that way. So if the angle is given here, the diagonal is always called the hypotenuse. All right, the hypotenuse is always away from the 90 degrees. That's constant. However, the side next to the angle will be called adjacent. So adjacent to the angle alpha, and the side away from the angle will be called opposite to the angle, okay, alpha in that case. So if the angle is there, then the vertical will be opposite to the angle alpha, away from, and this side horizontal will be adjacent to the angle alpha. Okay, so the sides will always be, the sides adjacent and opposite will always be in reference to the angle. Okay, so bear that in mind. Now, what if the angle was placed up there now? Okay, this side will remain the hypotenuse. The 90 degrees is always pointing to the hypotenuse. Okay, however, this side here now, the horizontal side will be opposite to the angle alpha because it's away from it, and this vertical side now will now become the adjacent to the angle alpha. Okay, so always bear that in mind when one of the acute angles are given. The two sides that form the 90 degrees will always be labeled in reference to the angle. Okay, now we are familiar with the sine function, the cosine function, and the tangent function. I'm sure we have heard of them already. The sine function, or the sine ratio, if you want to put it that way, is given by sine of the angle, is the side opposite to the angle alpha, in that case, divided by hypotenuse. Okay. The cosine of the angle alpha will be equal to the adjacent to the angle alpha, the side that is adjacent to the angle alpha. Okay, always in reference to the angle alpha. So cosine is adjacent, the side adjacent to the angle alpha divided by the hypotenuse. Okay, and the tangent now will be equal to tangent of the angle alpha will be equal to the side opposite of the angle alpha divided by the side adjacent to the angle alpha. Okay, and the three are commonly abbreviated as SO. Opposite, remember O is opposite to the angle alpha. Okay, and cosine is abbreviated CA, adjacent to the angle alpha divided by the hypotenuse, and tan is abbreviated TOA, opposite to the angle alpha divided by adjacent to the angle alpha. So take, for example, you have a triangle. Here you have an example, and you have a side that's labeled A. You have the hypotenuse because it's away from the 90 degrees, 29 centimeters, and angle 30 degrees. And you are required to, calculate the side A. Now you want to determine which trigonometrical ratio to use. So you make some observations according to how the triangle is, because you have to ensure that is the side opposite to the angle alpha that you have and hypotenuse so that you can use sine. So the right angle triangle, yes, it's a right angle triangle, so it's either sine, cosine, or tangent. And A now is the side opposite to the angle 30 degrees. So this is an indication that you may use in sine. So let's move on further. 29 degrees is the hypotenuse, right? So if 29 is the hypotenuse, A is the side opposite to the angle 30 degrees. The sine using opposite to the angle and hypotenuse, then you can use sine. So sine of 30 degrees is equal to opposite over hypotenuse. We are looking for the side A. A is the side opposite to the 30 degrees. So you just rearrange and you solve for A. You multiply 29 by sine 30 degrees to give you 14.5. Okay. Let's look at another example. Let's say you have a triangle and the side that is away from the 90 degrees H, that's what you want to find. And you have another side 81 centimeters and you have an angle 44 degrees. So you make some observations to pinpoint which trigonometrical ratio to use. First of all, it's a right angle triangle. That's obvious. The side H is the hypotenuse, okay, because you can see it is away from the 90 degrees. 81 centimeters is adjacent to the angle 44 degrees. 81 adjacent to 44 degrees. So therefore, if we are dealing with the hypotenuse and the side adjacent to the angle alpha, therefore you are in cosine, you are in CAR. So we have to use cosine of the angle is equal to adjacent over hypotenuse. We are looking for the hypotenuse. So we rearrange. Hypotenuse is 81 times 1 divided by cosine of 44 degrees, and that will give us 112.6 centimeters. Okay, and always remember the hypotenuse is always the longest of the three sides in a right angle triangle. And a third example, let's say you have a triangle, you have a side labeled T, you have 47 degrees, 47 centimeters on the other side, and you have another angle, you have an angle 35 degrees, and you want to solve for T. Again, you make your observations, it's a right angle triangle. As you can see, there's a 90 degrees. Side T is opposite to the 45 degrees, okay? So here you see T and it's away from the 45 degrees. So you have T opposite to the 45 degrees. The 47 centimeters is adjacent to the 45 degrees. So therefore you are dealing with opposite and adjacent. Clearly you are in TOA, that's tan. Tan is equal to opposite over adjacent. Tan 45 degrees is over 1 is equal to T over 47 because T is opposite to 45 degrees. 47 is adjacent to 45 degrees, opposite over adjacent. You solve for T by rearranging, you multiply 47 by tan 45 degrees to give 42.91 centimeters. So always bear in mind the proper labeling of the right angle triangle in order for you to use SOCA and TOA in your solution of the right angle triangle.